Hello grade 10s and welcome to yet another trigonometry lesson. Before we dig deep and dive into the really juicy parts of this chapter, I thought we'd start the lesson off with a little bit of a laugh. I'm sure you've picked up on the theme of these memes, and that is that it's very important to shade your rear because X-rays tan your exterior. What could I possibly mean? The theme is sunburn. What you need to remember is I'll repeat it, shade your rear because X-rays, I know the rays from the sun are actually UV rays, and I know that you spell exterior with an E at the front, but you're going to see now why am I harping on about sunburn and X-rays and shading your rear, because this is another mnemonic device. So far we have learned all about SOHCAHTOA. That's when we're using trigonometry in right-angled triangles. But today we're going to use that exact same concept. However, we're going to use trigonometry on the Cartesian plane and when we are given coordinates. So let's just go over this again. We know SOHCAHTOA, so we know sine is opposite over hypotenuse. But today I'm going to show you how opposite over hypotenuse can also represent a y over an r. And that is how you remember sine theta is y over r. We say sine shade your rear. Let me get a pointer option here. So S for sine is S for shade your rear. Y over R, your rear. And then cosine, cos. X over R, X rays. Tan, Y over X, your exterior. This will all come together in the following slides, but for now, if you can just remember to shade your rear, cos X rays tan your exterior. Pause the video, say it 10 times over, shout it at the top of your lungs, remember it. Right, let's have a look at triangles on the Cartesian plane. We are going to work in this very first quadrant. Remember, we've done functions, so you have heard about quadrants. Here, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. We always move through the quadrants in an anti-clockwise direction, and this is why they are labeled 1, 2, 3, and 4. I want you to imagine a point, any point plotted in quadrant 1. This example is going to call the point, it's going to give the x value of the point a number 3, and it's going to give the y value of the point a number 4. So remember, we can label coordinates with a semicolon in the middle, 3 and 4. Remember to put a semicolon. Make sure that symbol looks like a comma, a semicolon, not a colon. Otherwise, it looks like you're working with a ratio. So now we have a point in quadrant 1. If we were to connect this point to the origin, we could make a shape of a triangle. You could either make a shape of a triangle over here, or you could make a triangle over there. Now, for the sake of consistency, we are always going to make a triangle with the right angle degree sitting on the x-axis, okay? So the right angle must always be against the x-axis. Why? Because we create angles in an anti-clockwise direction, and so the angle that we are going to look at is going to be formed from the x-axis to the hypotenuse of the triangle in an anti-clockwise direction, and we are going to call that angle theta. Remember that the coordinate pair has an x value and a y value, so The x-axis has covered a distance of 3 units to get this side of the triangle. So I can move that 3 over and know that that side of the triangle is going to be 3 units. Likewise, this vertical line over here lines up with the vertical distance on the x-axis, and that vertical distance is 4. So I can call that side of the triangle 4 units in length. Now, what are we going to do in order to find that third side of the triangle, this hypotenuse right over here? Remember, trigonometry only deals with right-angle triangles. So, can we perhaps work with that hypotenuse and find its length? Of course we can. We can use Pythagoras to find the length of that hypotenuse. Now, the hypotenuse on the Cartesian plane is usually labeled r because r sounds like radius. And if you were to take a radius of a circle and rotate it round and round and round, it would be the same as rotating that hypotenuse. So r is always going to be the hypotenuse in shade your rear because x-rays tan your exterior. Now let's quickly figure out what the size of r is. I hope you all realize already that r is 5 because of the most beautiful Pythagorean triple ever to exist, number 3, number 4. If there's a 3 and a 4 connecting, meeting at a 90 degrees, then the hypotenuse will most certainly be 5. If you didn't know that, just substitute it into the theorem of Pythagoras in order to work out what your r will be. So, we now know that r is 5. Now that we have 3 sides of a triangle, can we perhaps work with our 3 trigonometric ratios? Let's think about it. Shade your rear. YR. Do we have a Y value? Do we have an R value? Yes, we do. Cos X rays. Do we have an X value? Do we have an R value? X and R. 3 and 5. Yes, we do. Tan your exterior. Do we have a Y value? Do we have an X value? 4 and 3? Yes, we do. So we can substitute in those relevant values, and so we have found the value of each trigonometric function for theta. Another thing that I'd like you to note is the sign of these answers. Do you see 4 over 5 is a positive number? 3 over 5 is also a positive number, and so is 4 over 3. This will come in handy a little later on, probably in tomorrow's lesson only. But for now, it's valuable just to note that all 3 trig ratios are positive in quadrant 1. Before we move on, say it with me. How are we going to remember these y's, x's, and r's along with the trig functions? We are going to say, shade your rear, because x-rays tan your exterior. Beautiful. Okie doke, so I'm going to pick up the pace a tad just because I'm repeating the exact same concept that was covered in quadrant 1, but for quadrant 2 now. The only difference is points in quadrant 2 will always have negative x coordinates and positive y coordinates. So let's, for example, use the same values, 3 and 4. However, because we're now in quadrant 2, we are now in the negative half of the x-axis, so the coordinate is going to be negative 3 and 4. X is now a negative 3, y is still positive 4. Let's make a triangle. Remember in the previous slide I said the right angle of the triangle must sit on the x-axis and the hypotenuse must connect to the origin. Now let's fill in the relevant values we've been given. The x was negative 3, so the bottom side of that triangle will be negative 3 units, even though a distance is always positive. Because we're working in the Cartesian plane, we're actually jotting down a value that lies on the x-axis. Y is 4, and how on earth do we find r? We use Pythagoras again. Just note, remember we had to rotate from the x-axis in an anti-clockwise direction. So the angle that we're working with actually starts here on the positive half of the x-axis, and it rotates in an anti-clockwise direction all the way to the hypotenuse. So the trig functions, so that is theta there on the outside of the triangle. The trig functions will refer to sine theta, cosine theta, and tangent theta. But we are actually pretending that the angle we're working with is that little star on the inside of the triangle. We call that our reference angle, all right? So we're working with that triangle and that acute angle that lies inside that triangle. However, it's very important to note that angles are labeled in an anti-clockwise direction, starting at the x-axis, ending at the hypotenuse, because later on you are going to be required to sketch this yourself, and you will lose a mark if you put theta here on the inside of your triangle, when the rule is theta is always measured from the x-axis to the hypotenuse in an anti-clockwise direction. I'll repeat. Yes, we're going to use the star. We're going to see what's opposite and what's adjacent, what's y and x and r. But it's actually a secret little reference angle that we're using. Right, remember, to find the hypotenuse, we use Pythagoras. I'm not repeating the steps, but we can see that r will be 5. So now, if we were asked to find the value of sine theta, cosine theta, and tangent theta, we could use shade your rear again. Sine of theta is y over r. Now, that little star is actually theta, although we never write it like that. And our y value, as you can tell, is 4, while our r value is 5. Likewise for cosine theta, we're going to pretend that little star is in the place of theta again. Cos x raised tan your exterior, x over r is negative 3 over 5. Lastly, tan your exterior, tan of theta is y over x, y is 4, and x is negative 3. Easy as that. So you'll be asked to find the value of the sine, cosine, and tangent functions when given a specific point in a specific quadrant. Let's just note again the signs of the answers. Sine in quadrant 2 is positive, cosine and tangent are negative. So sine is the only trig function that is positive in quadrant 2. Now say it with me. How do we remember x, y's, r's? We say shade your rear, because x rays tan your exterior. Right, same concept applied in quadrant 3. If you are given a point in quadrant 3, then your x value and your y value of the coordinate given will both be negative. Once you substitute those negative values into Pythagoras to find the value of the hypotenuse, you will see once again that r is 5. Despite the fact that 3 and 4 are both negatives, when you square them, they become positive. So your hypotenuse, your r value, will always, 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 always be positive, even though your x values and your y values can change sign depending on the quadrant that they're in. Once again, remember that we measure angles in an anti-clockwise direction, starting from the x-axis, ending at the hypotenuse. So that big angle, it's a super obtuse angle, that is actually theta. However, we work with the secret little star of the acute angle inside that triangle. Now let's go and see the values of our sine, cosine, and tangent in quadrant 3. If you substitute in the relevant y's, r's, and x's, you will see that the only positive trig function in quadrant 3 is the tangent function. Are you ready for quadrant 4? Rightio, let's do this thing. Once again, a triangle sketched in quadrant 4, when given a coordinate, will have a right angle sitting on the x-axis, and that angle will be measured in an anti-clockwise direction. This triangle, using the Pythagorean triple again, will show us that the hypotenuse is 5, and there I've shown that the angle theta was measured in an anti-clockwise direction, but our secret little reference angle is that star. Now let's substitute in our relevant values. Shade your rear. Sine is y over r, so it's negative 4 over 5. Cos is x over r, which is positive 3 over 5. And tan is y over x, which is negative 4 over 3. We have found the values of the three trig ratios. Please excuse the little pink star that's decided to randomly sit in front of tan there. That's quite irrelevant. Righty, let's have a look at the signs. Cosine is the only positive answer for quadrant 4, so only cosine is positive in quadrant 4. And there we have covered the introduction to the cast diagram. This little diagram over here is a mere summary of the conclusions we made in the previous slides, and we will deal with this more. We'll deal with more of this tomorrow. For now, I'd like to present you with the examples that will help you with your homework today. Right, let's have a look at this coordinate P plotted in quadrant 2. I hope you can remember that sine was the only trig function that was positive in quadrant 2. However, to deal with the trig functions, we need three sides of a triangle. So here they're asking us to calculate the length of OP. In other words, they want us to find the R value. Remember that a coordinate is always an x and a y, so we can see that the distance covered on the x-axis is negative 12, while the distance covered on the y-axis is 5. Thank you, dear Pythag. We appreciate you. We love you. Thank you to Pythag. We can find the length of OP, and hopefully you also know the Pythagorean triple 5, 12, and 13. So the radius of this triangle, the R, is 13. Now that we have all three sides of the triangle, can we find the the trig functions, sine, cosine, and tangents? Of course we can, because we're going to know that shade your rear. Sine alpha is equal to y over r. So our cos alpha is equal to x over r, cos x raised, and tan your exterior. Tan is equal to y over x. So let's fill in our relevant pieces of information, and voila, you've answered the question. Let's do this quick example number 2 before we leave you to do your homework. Here we are given a coordinate in quadrant 3. I hope you can remember that tangent was the only trig function to be positive in quadrant 3. And here we asked first to find the value of x. Everything we've done up until now actually gave us the value of x, and we were using x and y to find the value of the hypotenuse. Here we are given the hypotenuse as 17, and we need to use Pythagoras once again to find the value of x. That's super easy. We just do a subtraction sum. Note how this triangle has its right angle sitting on the x-axis, not here against the y-axis. And if we use Pythagoras, we just have to subtract 15 squared from 17 squared, square root your answer. Thank you, Pythag, for helping us. And then we know that x is 8. However, look at how this triangle, this distance covered on the x-axis, is on the negative half of the x-axis. So it's not actually x equals 8. It's actually x equals negative 8. So fill in that information and fill it in correctly. If you were to make a sketch of this and if you failed to put negative 8 in your sketch, you would lose a mark. All right, so just be careful and be wary of in which quadrant we are working. Now that we know that, now that we know all three sides of this triangle, we can apply the shade your rear concept. So if we are asked to calculate the value of sine alpha plus cosine alpha, we can substitute in their y over r and x over r values, because sine is y over r while cosine is x over r. Our y is negative 15 while our r is 17, and our x is negative 8 while our r is 17, and that can simplify to negative 23 over 17. And that is that. Notice how when you are asked to find the value of a trig function at alpha, you do not have to find the value of alpha. We are merely substituting in values and simplifying. If we asked you to find alpha, the size of that angle, then you would have to use your calculator and press shift. But that is only going to come at a later stage. We've already practiced using our calculator in that regard, and you actually never really going to use your calculator to find alpha when faced with questions involving this diagram called the cast diagram. Anyway, good luck for your homework exercise today. We'll carry on with this tomorrow. Enjoy.